In this presentation, we have to solve few problems from the gamma function. First problem is prove that gamma of n plus 1 is equal to n gamma n. To prove this, first of all, we should know the value of gamma function. Gamma of n is equal to limit varying from 0 to infinity e power minus x power n minus 1 into dx. This is the value of gamma function. Say this is equation number 1. In this equation 1, put n is equal to n plus 1. Then gamma of n plus 1 is equal to limit varying from 0 to infinity e power minus x power n plus 1 minus 1 into dx, which is equal to limit varying from 0 to infinity e power minus x power n into dx. Now we have to solve this using the formula integral u dv. See, we have to solve this integral. For that, we have to use the formula integral u dv equal to uv minus integral v du. Here, u equal to x power n, then dv equal to e power minus x into dx. This is u, e power minus x into dx is dv. Then gamma of n plus 1 equal to uv. The value of u is x power n. dv equal to e power minus x into dx. v equal to integral dv, that is equal to integral e power minus x into dx, which is equal to e power minus x by minus 1. This is minus e power minus x. So instead of v, we have to put this value e power minus x with a negative sign. Now we have to apply the limit 0 to infinity. Then minus of integral v du. The value of v is e power minus x with a negative sign, so minus to minus plus. Then du. Here u equal to x power n. Therefore, du equal to n into x power n minus 1 into dx. This is the value of du. Put this here, n into x power n minus 1 into dx. This is equal to minus x power n e power minus x, limit varying from 0 to infinity, plus take this n outside, n into limit varying from 0 to infinity, here also 0 to infinity, e power minus x power n minus 1 into dx. Here this quantity is 0. This is n e power minus x power n minus 1 dx, limit varying from 0 to infinity is our gamma n. Therefore, gamma of n plus 1 equal to n gamma n. We have proved this. The second problem is prove that gamma of 0 equal to infinity. To prove this, take this equation gamma of n plus 1 equal to n gamma n. Here gamma of n, which is equal to gamma of n plus 1 by n. In the above equation, put n equal to 0. Then gamma of 0, which is equal to gamma of 1, because 0 plus 1, 1. Gamma of 1 divided by 0. Anything by 0 is infinity. Therefore, gamma of 0 equal to infinity. Then our third proof, prove that gamma of 1 equal to 1. For that, take the value of gamma n. Gamma of n is equal to integral limit varying from 0 to infinity e power minus x power n minus 1 into dx. This is the value of gamma of n. Then replace n by means of unity. Gamma of 1, which is equal to limit varying from 0 to infinity e power minus x, then x power 1 minus 1 into dx, which is equal to 0 to infinity e power minus x, x power 0. X power 0 is 1, so e power minus x into dx. If we integrate this, we can get e power minus x by minus 1, that is equal to minus e power minus x. Now we have to apply the limit 0 and infinity. This is equal to minus e power minus infinity, minus limit minus into minus plus e power 0. E power minus infinity is 0, e power 0 is 1, that is equal to 1. Therefore, gamma of 1 is equal to 1. Next proof, problem 4. Prove that gamma of 2 equal to 1. We know the formula gamma of n plus 1, which is equal to n gamma n. Here gamma of 2, which is equal to gamma of 1 plus 1. Here the value of n is equal to 1. N plus 1 form we have arranged. Therefore, gamma of 2, which is equal to 1 gamma of 1. We know that gamma of 1 equal to 1. Therefore, gamma of 2 equal to 1. Next problem is prove that gamma of 1 by 2 is equal to root pi. To prove this, you should know the relation between beta and gamma function. Beta of m comma n equal to gamma m into gamma n whole divided by gamma of m plus n. This is the relation between beta and gamma function. Now, gamma m into gamma n, which is equal to beta of m comma n into gamma of m plus n. Just I have cross multiplied this. This is equal to this into this. But the value of beta of m comma n is equal to limit varying from 0 to infinity x power n minus 1 whole divided by 1 plus x power m plus n into dx. This is the value of beta of m comma n. This is standard integral. Therefore, gamma of m into gamma of n, which is equal to this m plus n, gamma of m plus n into integral limit varying from 0 to infinity x power n minus 1 whole divided by 1 plus x power m plus n into dx. Now put m plus n equal to 1. Therefore, n equal to 1 minus m. Substitute these values in the above equation. Gamma m into gamma n. Instead of n, we have to substitute 1 minus m, which is equal to m plus n is 1. Gamma of 1 is 1. Integral limit varying from 0 to infinity x power n minus 1 whole divided by 1 plus x into dx, because here also m plus n equal to 1. Here also m plus 1 equal to 1. Gamma of 1 equal to 1, so this is ruled out. Integral limit varying from 0 to infinity x power n minus 1 divided by 1 plus x into dx. This is the standard integral. The value of this integral is pi divided by sin m pi. This is the value of this integral. Here the left hand side is gamma m into gamma of 1 minus m. Now put m equal to 1 by 2. Here gamma of 1 by 2. Here 1 minus 1 by 2, which is equal to pi divided by sin 1 by 2 into pi. This is equal to pi divided by sin pi by 2. Sin pi by 2 is 1. Therefore, this is pi. The left hand side is gamma of 1 by 2 into 1 minus 1 by 2 is also 1 by 2 into gamma of 1 by 2, which is equal to pi. Therefore, gamma of 1 by 2 is equal to root pi. Now we have proved this value, gamma of 1 by 2 equal to root pi. Problem number 6. Prove that gamma of 3 by 2 is equal to root pi by 2. For that, write down this gamma of 3 by 2 in the n plus 1 form, that is 1 by 2 plus 1, because gamma of n plus 1, which is equal to n gamma n. Now the value of n plus 1 is equal to 1 by 2 plus 1. 3 by 2 is 1 by 2 plus 1. This is equal to, using this formula n gamma n, here the value of n is 1 by 2. 1 by 2 into gamma of 1 by 2. See this, gamma of 3 by 2, which is equal to 1 by 2 plus 1. This is gamma of n plus 1. This is actually gamma of n plus 1. N is 1 by 2 plus 1. Gamma of n plus 1 is equal to n gamma n. Here the value of n is 1 by 2, then gamma n. We know that gamma of 1 by 2 is root pi. Already we have proved this. Therefore, gamma of 3 by 2, which is equal to root pi by 2. Next, the problem number 7. Prove that gamma of 5 by 2, which is equal to 3 by 4 root pi. Now we know that the gamma of n plus 1 is equal to n gamma n. So in this form you have to write this 5 by 2. Gamma of 5 by 2, which is equal to gamma of 3 by 2 plus 1. Here n is equal to 3 by 2. Therefore, gamma of 5 by 2, which is equal to 3 by 2 gamma of 3 by 2. But gamma of 3 by 2 is 1 by 2 gamma of 1 by 2. Therefore, 3 by 2 into gamma of 3 by 2 is 1 by 2 gamma of 1 by 2. This is equal to 3 by 4 gamma of 1 by 2. But gamma of 1 by 2 is root pi. Therefore, this is 3 by 4 root pi. Now we have proved that gamma of 5 by 2, which is equal to 3 by 4 root pi. Then the 8th problem is prove that gamma of n is equal to n minus 1 factorial. You know that gamma of n plus 1 equal to n gamma n. Therefore, gamma of n, which is equal to n minus 1 into gamma of n minus 1. See here, gamma of n plus 1 equal to n gamma n. Therefore, gamma of n equal to n minus 1 into gamma of n minus 1. But gamma of n minus 1, which is equal to n minus 2 into gamma of n minus 2. Then gamma of n minus 2, which is equal to n minus 3 into gamma of n minus 3. The series is going on. Therefore, gamma of n, which is equal to n minus 1 into n minus 2 into n minus 3. Here we have to put gamma of n minus 3. This series is going on. Then this is ended with n minus 1 factorial. If you understand more about this, find out the value of gamma of 5. Find out the value of gamma of 5. See, this is problem 5. Gamma of 5 is equal to 4 factorial, because gamma of n is equal to n minus 1 factorial. 4 factorial is equal to 1 into 2 into 3 into 4, which is equal to 3 into 2, 6, 6 into 4, 24. So gamma of 5 equal to 24. In general, you may write gamma of n plus 1 equal to n factorial. This value, gamma of n plus 1, this is equal to n factorial. Gamma of n plus 1 is equal to n gamma n, that is equal to n factorial, whereas gamma of n equal to n minus 1 factorial. In this way, we have to solve the problems.